Hi, I'm Jay. Today I'm going to talk about a research topic that I done previously, using VAE-pix2pix to generate realistic terrain. So what is our research problem? First, generating terrain is a complicated task. Designer may take lots of efforts in fine-tuning the terrain to let it look realistic. So we want to find an effective way to generate terrain. And if there is an effective way to generate terrain, can we adjust the style of the generated terrain? So let's talk about the literature review. For generating terrain, there are mainly two methods to generate terrain. The first one is hydraulic erosion. Hydraulic erosion method can stimulate erosion and the deposition caused by water flow, thus changing the shape of the terrain. However, these methods need to adjust lots of parameters and takes a lot of time to generate terrain. And the second method is using pix2pix model. After training, pix2pix model can generate different kinds of images, including height maps and the satellite images. But we can't adjust the style of the generated images. So this is the effect of hydraulic erosion. And this is some pix2pix applications that it can make this day image into the night version of it. So let's talk about our methodologies. So we first built a neural network called VAE-pix2pix, which composed with the variation autoencoders and pix2pix. This is our variation autoencoder, this one. And after we get the Latin code, we upsample it to 8 times 256 times 256, and we concat it with our blur height maps, and we make these factors sent into the pix2pix model, and pix2pix will generate a fake height maps and a fake satellite images, and we compare it with the real images and calculate the L1 loss. So we collect height maps and satellite images to train our original pix2pix and VAE-pix2pix. Then we compare the difference with VAE-pix2pix and with traditional methods. And this is one of our training data. The left one is the blur height map, and the middle one is the satellite images, and the right one is the real height maps. So this is our result. We input these blur images, and the original pix2pix generates these satellite images, and VAE-pix2pix generates these images, and the red one is the ground truth. And hydraulic erosion method can generate satellite images, so this is none. And this is the height maps that generated by hydraulic erosion method, and this is generated by original pix2pix, and this is by our method, and this is the ground truth. As you can see, our method is the images generated by our method is closer than the ground truth than the original pix2pix and hydraulic erosion method. So this is the matrix we run to compare the performance on the original pix2pix and VAE-pix2pix. As you can see, in most of the matrices, our method is better than other traditional methods. And this is the mapping done by the style encoder from 5 region to an 8-dimensional latent space. And this is the screenshot of our United client. The user can draw a rough structures of the terrain, and our VAE-pix2pix model will generate a realistic terrain like this, and it can also generate the corresponding satellite images. And this is our in these features we using different regions latent codes on different parts of images. So the left bottom corner is the latent code of Canada, and the right bottom part is Argentina's latent code, and the left up part is the Peru latent code, and the right top is the Himalaya, the latent codes. So in conclusion, our VAE-pix2pix model can generate more realistic time maps and satellite images, and it allows its user to freely adjust the style of the generated images. The United client we develop allow our model to be directly applied to the game development, which also integrates the two-step process of generating realistic heat maps and the corresponding satellite images into one step. This makes generating realistic mountain models for game development much simpler. And this is our references. So this is my short introduction of what I have done previously. Thank you.